Hey everybody. So it is Monday the 20-something of June and I am doing a Shineponics update. Last week, okay, I think this is video 3, although it will be number 2 because arrays start at index position 0 and I thought that would be a funny way to number this series, so that's happening. So I had to sort out quite a few personal things last week, so I didn't have loads of time to work on Shineponics stuff, sadly, but there is something quite cool I would like to show you. So let's jump over to that. Okay, so here's what I wanted to show you guys. You will see I'm in a file called shinode.ts. This is a TypeScript file. Of course, we can't run TypeScript on an Arduino. That's, well, maybe possible, but not without a good bit of jiggery pokery and some wrangling of code and compiling some blah 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 blah. It's not going to be easy. So I'm not going to directly take this TypeScript code and put it onto the device. What I have realized I can do is I can actually write out a class in TypeScript, a nice class defining logic for a device, and then I can use ChatGPT to help convert that class into a C++ class. This was a mocked up C++ class that I wrote with some comments and stuff to sort of illustrate the logic that I wanted to put in the class, and then I realized it was going to take me forever to figure out the C++ to fill in the class properly, but I could fill in the logic of a class in TypeScript very easily because I write TypeScript all the time. I live and breathe TypeScript. So here's the class in TypeScript now. So here was my prompt to ChatGPT. Please convert the following TypeScript class into a C++ class for use with Arduino. The client property of the Shinode class should be an instance of Wi-Fi client secure. And so Wi-Fi client secure is something that is in the Arduino libraries for making network requests. Of course, it doesn't exist in the JavaScript world. If we scroll past these types that I've defined up here, and we get to the actual Shinode class definition, you will see that I gave the client property of the class the type of the fetch function in JavaScript. And we can see this code here. Here is the class, and so the constructor function receives the device ID, the device's connection token. So this is a secure authorization token generated by the web server that currently doesn't exist but will soon come. This client is what makes HTTP requests inside the functions here in the class. The reason that this comes as a property of the class is because we have to first set up the client on the Arduino with our encryption certificates to the server and all of this sort of stuff, which we can see here. This is just a temporary server address. I will change this to be shineponics.org or whatever. And then each device has sensors and controllers, and the types for those are defined at the top of the file here. Very nice. So what we see in the constructor is we make a request to the client with our token as an authorization header. We get that data back, we turn it into JSON, and then we set the polling interval of the device, so how often should we poll to the server. Then we do some synchronization of the sensors and the controllers from what the server has given back, just to make sure the device on the server has been configured correctly. And then we call sense, and sense method here loops through all of the sensors that we have and senses them by reading their data. And so we get all of these results from all of our sensors. I've done a wait promise to all in case it's asynchronous, but it might not be. And then we make a post response to our server again. Now again, this host name should probably be configurable, which it will be, but we make a post request to our server with our sensor data. Control does exactly the same thing. We get results by taking control actions and posting those control action results to the server again. The only difference is that control takes actions, so we will be given actions from the server And where do those actions come from? Well, they are returned from the sense function. So a sensor senses along with all of the other sensors, and when all of the sensors on all of the devices have sent their results, the server computes any control actions for devices and sends them back to the corresponding devices that should take a control action. So our device here receives some actions from its sense function, and then it will perform those actions as controls. And so this class was pretty easy to write in TypeScript. Could not write that in C++ efficiently at all, but we didn't need to because ChatGPT did it for me. And if we look at this, we have the structs at the top, then here we get into the class definition, we have the private variables, just like what we saw on the TypeScript class, but now we get into the client logic, which I had not even filled in the class, and we can see ChatGPT has been smart enough to fill it in for me here. And so here we are checking that both our sensors and controllers both match the server's data, and then we call the sense method like we saw in the TypeScript class. Sense goes and reads sensors from all of our sensors. Let's see if I can get horizontal scroll. Oh wait, I didn't need a horizontal scroll, did I? So we can see for the length of the sensors array, basically for each sensor sense, and then print that into results, and then we post those results to the website here. Here we go, control. So here we have the control method, takes actions, and similarly has some slightly more complicated code, and then we have sync, which is exactly like what we saw in TypeScript code, which is just checking, has it been long enough, taking the polling interval into account. If we've polled longer than the polling interval in the past, then yes, let's do a sense and control. And so it's actually looking pretty nice, this C++ code. ChatGPT has done a wonderful service here. What I should be able to show you guys in the next video is me actually implementing this class onto the devices and then setting them up on the cloud. But I wanted to just run you through this C++ class that I now have and my really nice workflow of writing in TypeScript first and then getting ChatGPT to do the conversion for me. Anyway, that is all for now. I'm sorry I didn't have more exciting stuff to show you in this video. I promise there will be some cool stuff coming soon of some actual devices working in the real world on my balcony, feeding some tomatoes water and all of that good stuff. But for now, I'm manually watering my tomatoes. I know, sad, but it is what it is. Stay tuned. Next week should be really cool. We should actually put this class into action and you'll be able to see lots of cool stuff come together. So, peace.